attack against MySpace back in 2005, where the bad guy constructed a site profile for himself, which was architected such that whenever somebody visited his web page, it would automatically add them as a friend. Right? His site profile had some HTML, which made a write request, back to MySpace, and basically it was architected smartly enough that if any of his friends' friends happened to visit, any of his friends' profiles, then they would also get added as his friend. So within like a 6-hour period, he got like 1 million friends, and MySpace had to shut down their site in order to deal with this problem. So cross-site request forgery can be quite damaging. How many of you have heard of drive-by farming attacks? Okay, a few. So drive-by farming attacks are yet another example of a cross-site request forgery attack in which, because of the fact that most home users don't change their default credentials for their wireless access points, bad guys are able to architect web pages that will go ahead and try to make write requests to addresses like 192.168.0.1 to change the DNS settings that the router happens to be using. And once the attacker is able to change your DNS settings, then it's kind of game over, because when your browser decides to make a request to bank.com, the DNS will tell it what's the IP address for bank.com. So the attacker can, of course, substitute whatever address he or she would like and take the user to evil.org, even though the URL bar will say bank.com. So for those of you that are familiar with drive-by farming attacks, they're just another example of cross-site request forgery at work. How do you prevent these kinds of attacks? Well, let me talk about a couple methods that won't work, and let me talk about a couple methods that will work. So one thing that, if you know about the HTTP protocol, you know it supports a referrer field, where every time that you get a request for a web page, every time that a web server gets a request for a web page, it gets a referrer header telling the web server what was the previous site that the user visited. Now, in our previous example, where the cross-site request forgery took place, bank.com's web server, when it gets the HTTP request to pay the bill, it'll get a referrer, and the referrer will be evil.org. Why? Because evil.org was the entity that sent back the HTML and/or JavaScript snippet saying, please issue this bill payment request. Unfortunately, web servers don't always get referrer headers, right? A user, for instance, that is using an HTTP proxy for anonymity, the proxy will go ahead and eliminate the referrer headers. So there's lots of legitimate reasons that referrer headers might get stripped out. So simply, if you want to prevent cross-site request forgery attacks, looking for the referrer header and only conducting the action that the user requested. If you see the appropriate referrer header, might not be the best approach. A lot of this won't work for a lot of your users. You might say, oh, okay, well, I'd like to use a web application firewall, something like mod security, like I did previously to prevent the SQL injection attack. Let me try to write regular expressions to look for dangerous input. Well, this solution doesn't work either, simply because there was no malicious input. From bank.com's standpoint, it's a completely legitimate request. It just happens to be issued by another site, not bank.com itself. So web application firewalls are not in the best position to prevent this kind of an attack. On the other hand, there might be some approaches that can work. So if, for instance, you ask the user to type their password again before issuing the bill payment, then that solution will work. Why? Because in order to forge a request, the attacker would then also have to know the user's password. But if the attacker knows the user's password, they could probably do a lot worse things as well. So this is an example where you ask for a user-provided secret, a secret that only the user and the bank.com site know, but that the attacker won't know. Validating the request by asking the user to provide a secret is a good way of preventing cross-site request forgery attacks. Finally, you can imagine that this might be more inconvenient to users, and you might want an approach which doesn't require the user to enter the password again. So what you could do is use what's called an action token, and I don't have time to properly describe action tokens in all their depth, but the idea is that every time that bank.com gives a web page to the user, it will, in addition to all the information that's already there with regards to form that the users could fill out to submit actions, the server also generates a cryptographic authentication code that goes into that request that's created with a key that only the server knows. And then when the browser issues further requests, the server looks for that message authentication code. And so basically, if a attacker wanted to forge requests, it would have to know the server's key in order to generate an appropriate token to get past the check on the server. So using action tokens is another approach, and all of this is described in Chapter 10 of the book. So now that I've talked about two vulnerabilities in particular, I kind of wanted to step back, talk about some overall trends in the area of web application security, and recommend some areas where you can go to learn more. So this chart shows some information that I aggregated from a report that MITRE put out. And what it does is it shows the number of security vulnerabilities due to various causes that were reported between the years 2001 and 2006. And what we can see is that cross-site scripting, XSS, and XSRF for this purpose, I believe, is lumped in there. These types of attacks have been increasing dramatically over the past couple years. Attacks due to PHP include code injection vulnerabilities have also been growing. Attacks due to SQL injection, the upside-down triangles, I know it's a little hard to see on the slide, have also been increasing. And then finally, DOS attacks and buffer overflows have continued to be issues, although they're not increasing at the same rate as these other vulnerabilities. What should you take away from this? Well, these types of attacks are increasing. I showed you some information from the MITRE vulnerability database, but there's many other vulnerabilities. For instance, Security Focus has a vulnerability database. I looked at a couple different vulnerability databases, but regardless of which one you look at, the big four types of vulnerabilities are about the same across the different databases. So cross-site scripting, Cross-Site-Request-Forgery, cross-site script includes, lumping all of these together are the #1 growing web-based vulnerability threat. Code injection attacks, for instance, SQL injection and PHP include types of attacks follow. And then, of course, memory corruption of various types, buffer overflows, integer overflows, format strings, and denial of service are also big issues. So these are the big four that you need to look out for when developing your web applications. What should you do? Well, if you're an engineer, a developer, a programmer, software architect, if you serve any of these roles in your organization, the first thing you need to do is you need to arm yourself. You need to make sure that you have a deep understanding of how these attacks work and how to defend against them. So I'm going to recommend a couple resources that you can go to learn more, and basically what you should learn. And then secondly, you should do things like for each project, for each software project, there's a lot of pressure to just get the application working and deployed, and so doing things like electing a security czar for the project might be a good idea, where that security czar takes on the responsibility of auditing the code and making the right decisions with regards to influencing people to watch out for these vulnerabilities. Let me get a little bit more specific. So I said arm yourself. Well, how do you arm yourself? What do you need to know? This slide shows what I think every engineer needs to know about security, and it's broken down into a couple parts. The first thing that I think every engineer needs to know about is secure design principles. Things like the principle of least privilege, fail-safe stance, how to secure the weakest link first. And it's important to have these principles in mind, simply because it's going to be impossible to teach everyone what each type of trick that the attackers play are, right? So actually, let me ask, how many of you got CS or EE degrees? Okay, how many are you in the process of getting CS or AA degrees? Okay, more. Good.